saw that if we now have our base 5 number system, we're counting places, however many the quantity may need. We're counting 1s here, then we're counting 5s, then 5 squared, 5 cubed, and so on as we need them, depending on the quantity. There's really no, okay, so in any place then, our options for what this could be, well, I can't have 5 because then it rolls over to the next place. So I'll have a 0, 1, 2, 3, or 4. And those symbols evolved over time to what we have today. So these are our options for any single place. And you see the number of options is the same as the base value, 5. Because I'm starting at 0, it goes up to 1 less than the actual base value. So 0 to 4. Now, nothing prevents us from looking at another group size. Why 5? Well, the 5 sort of came from the African tribes, and I just ran with it. But there's no reason it has to be 5. The Babylonians chose 60. Well, that's a little high for my liking. But we can choose other numbers. We can choose any base number. Choose any, let's say, base value. What about 6? What about 8? What about 12? What stops us from doing that? But then as the base value changes, if I have another one, then the options will change as well. For example, if I have a base 7 system, then I'm going to count in 7s. I'm going to count 1s. I'm going to count groups of 7, 7 squared, 7 cubed, and so on as I need it. And the options for every single place, the options will change 0, 1, 2, 3, 4, 5 to 6. Because as soon as I have 7, then it rolls over to the next group. So the group size is actually kind of arbitrary, that I can choose another one. And everything works the same, I just have to count according to that group size, that base value. So all we're going to do now is just let the base change. And every question will have its own base. And just practice that, but it works exactly the same as base 5. So we're doing this all by example because there's no new concept other than just noting that I'm counting in different powers of that specific base. And the options change according to the base value. So let's just practice that and we'll see if there are any differences, anything we need to be concerned with. Exercise 7 point, I don't know. 7.7. That's a convert back and forth question. First, given a base value number, again it's indicated by the little subscript, which tells me how I'm counting, what the places represent. Convert that to a decimal number. So I have 3315 base 8. So now I'm counting in 8s, meaning this counts the 1s, that counts the 8s, that counts the 8 squared, that counts 8 cubed. So this represents, I'll do it over here, 3 groups of 8 cubed, 3 groups of 8 squared, 1 group of 8, and 5 ones. Put that into your calculator, and you get the number. Simple as that. Nothing new really, other than I'm counting now in 8s instead of 5s. What is the answer that you get?
1,741.
1,741. That number does not have a subscript because it's a decimal number. Though if you want to give it a subscript 10, that will be okay as well. But we drop the subscript and then agree that will be our decimal number. Pretty straightforward if you followed along with what's been happening in the previous couple of classes. Very little difference. So I don't get tied up with the 5. It can be anything. The 5 was just a convenient choice. Nothing more really. We'll keep going with B. B, I have 3213 base 4. Notice that whatever the base value is, the digits cannot be that value or higher. So I can't have a 5 in here, or a 4 or anything. The options are limited by the base value. So now this counts 1s again. That counts the number of 4s. That counts the 4 squared. That counts 4 cubed. So my representation is in decimal calculated as 3 groups of 4 cubed, 2 groups of 4 squared, 1 group of 4, and 3 little ones left over. Calculator says 240. Can anyone confirm her 240? Or we just accept it? Or is she tricking you?
Oh, I did screw it up. It's 230.
See, she was testing you. Of course on purpose. 231. So, that, again, that's why showing a little bit of work just makes it safer that if that happens and it wasn't on purpose, I can still give you something because I can see that you know how to do it. It was just a little silly mistake. But if you just write 240 and nothing else, I have nothing to give you. Because you gave me nothing. 7550 base 9. Now we're going to keep the base value small, manageable. We're not going to go to the 60s and things like that. But you could technically have anything. This now counts 1s, 9s, 9 squared, 9 cubed. So it is 7 plus, not plus, 7 groups of 9 cubed with 5 groups of 9 squared with 5 groups of 9. That was supposed to be an S, let me just get rid of that. Plus 0 ones. Calculator says, it's actually too simple. I apologize.
5,553.
5,553. Yes?
Just a quick clarification thing. For the second step where we're doing like 7 times 9 cubed, can we reverse it to do
Doesn't
like
matter.
0 times 9?
Yeah. I don't know why I do it this way, because we tend to read and do stuff left to right. But in order to figure out what the places are, I do have to go right to left.
Okay.
So you might as well just write them right to left. It doesn't matter at all. I'm just adding them all together in the end anyway. Whatever feels the safer option to you. Any other questions or comments? I don't want to do too many examples. 3 I feel is a nice compromise. Now, in number 2, we are given 5,094. And we want to represent that in different bases. First, base 3. 5,094 would then have to be broken up so I can see, well, I don't even know how many places I need. A place for the ones, then I count threes, then 3 squared, then 3 cubed, and if the quantity is big, I need to keep going and going and going. What is 3 to the 4? 81? Oh, that's seriously small. What is 3 to the 5? 243, that's also pretty small. So let's suppose you just guess. 243, which is 3 to the 5. What would that question mark value be? How many 3 to the 5s can fit into 5,094? Well, you do 5,094 divided by 3 to the 5, and you get 20? What does that 20 tell you? 20 is not one of my digits, meaning the 3 to the 5 was not big enough. I can fit something bigger in. Well, it's 3 to the 4. 6 I mean. 729. 3 to the 7.
2,180.
That's still good. Let's try 3 to the 7. How many times does 3 to the 7 fit into 5,094? 2 times. I have a digit for 2, so that would be good. Then I have an amount left over. So the 5,000 amount minus 2 times, or minus this. What do I have left over?
715.
715. And then I just keep going. Write this down. Now 715 is how many groups of 3 to the 6? 3 to the 6 was? 720. So clearly that's a little bit too big. But I do want to list it because that's a place. There's a place for the 3 to the 6 that I have to keep empty. So then I'll go down to 3 to the 5. Still having 715 left. How many times does 3 to the 5 fit into 715? 2 times. And how much do I have left over? $229. Now it's important that we don't make a mistake sort of in the middle here, because then everything after that's going to be wrong. Can anyone confirm 229?
Is this 715?
It's 720.
It's
Yeah,
720.
740.
Didn't someone say 715? Did I just hear that in my head? No one said 715. That was all me. Really? Wow, that's embarrassing. I thought you said 3 to the 6 is 720.
729.
729.
Wow, why didn't you say something here instead of waiting there? So this is all nonsense. So what is that number? 720. Where on earth did I get 715? Who knows? 3 to the 6, you said is 729. Okay, so the 0 is still good. Now, I fit in 2 groups of 3 to the 5 into 720. How much do I have left over? Wait, what you said correct? Probably not. So from 720, take away 2 groups of 3 to the 5. $244. I just need triple check that I'm hearing. 254?
33.
See, clearly at my age, the hearing is the first thing to go. Because I think that's what they say. I can't hear them. So I keep going and going. This one's definitely a little bit more tedious in terms of the time that is required here. Why do I? Yeah, okay. Plus, now 234. Well, 3 to the 4 is 81, so I can fit a couple in there. How many? 2 groups of 3 to the 4. You can also do it on the side here if you want to. How much do I have left? You can, because it's a lot. It's up to you how much you want to write down. So I use 3 to the 5, and I have left. Use 3 to the 4 at this point. And how much do I have left from 234? 72. Then I'm going to use 3 cubed, which is 27. How many 27s fit into 72? 2. So I can keep going here. 2 times 3 to the 3. And I have left 15. 18. Triple verify what's happening here. Then I fit in 3 squared, which is 9. 2 9s. I have nothing left. So that means no 3s and no 1s. Quite the process. A lot of opportunity for mistakes. So this number, base 3, is 20222200, base 3. And it's so long because base 3 doesn't give me a lot of options for every place. I have little groups, small number every time. So the representation gets really long. That was fun. No? It was fun for a while, and then my hearing let me down. What's going to happen when I'm actually old? That's a problem. B. Now, bigger base values will just make the representation shorter, so it will be a little faster. Now, base 5. We've done base 5, but it's just another base, just as important as any other. So now I'm looking at groups of 5. Luckily, I'm more familiar with 5. So I know that 5 to the, what is the largest power that I can fit in? 5 to the 5? How many 5 to the 5s can I fit in? How many? Just 1. Oh. How many do I have left over? Well, let's make a table. Why not? The table might be a little nicer. So I have my digit. I have my, I guess, power of 5. And I have what's left over. So right now, originally, the whole 1594 was left over. I fit in 1 5 to the 5. So this times this, take that away from the previous leftover amount, and I have leftover 1.
$1,969.
All right. Then I'm fitting in a power to the 5 to the power 4. How many of these can I fit in? That's 625. A couple. 2 of them. How much do I have left over if I take 2 5 to the 4s away from 1969?
It looks like 1,919.
I have 1,000 left.
Oh, it's probably 4. Never mind.
You have 94.
94. Whatever I have left has to be less than 625. Otherwise, this isn't big enough. Then I go to 5 cubed, but I know that's 125, and I won't be fitting any of that into 94. So I go to 5 squared, which is 25, and I can fit in 3 of them for a 75. 94 minus 75, that becomes a little easier. No? What did I say? 75. 3 25s is 75. 94 minus 75, 19. Running out of space a little bit. I think we're okay actually to keep going now. So we don't really have to write that down, but I'm going to. 2 groups of 5 to the 4. 0 groups of 5 cubed. 3 groups of 5 squared. Now I have 19 left, so I can fit in 3 5s, and that will get me to 15, so I have 4 left over, or 4 1s. So the representation is 1 2 0 3 3 4 base 5.
I think there was 3 5 and 4.
What?
I've got 3 for my second number. Yeah, but I'm sleepy.
I agree.
Yeah, me too.
Which number? Which number?
This
one?
Power 4, yeah.
Yeah.
Someone said 2 though, no? No one said 2, it was just me?
They were wrong.
That means everything else is nonsense.
No, I don't think everything else is fine.
Yeah.
And
No, but-
I think it was just the final write-up.
So when I wrote a 2 here,
That's why you had the
someone
1,000
still
left.
subtracted 3.
But that's why you still had the 1,000 left over and you're confused, so then we're like, no, it's actually not
Another
that,
one.
so it's another one.
Oh, so I just update this to
Yeah,
3.
yeah, correct.
Okay, that's not so bad. All right, all right. We're of course doing all this on purpose to illustrate that this way to convert is much more tedious and it's much easier to make a mistake. Which means I have to be even more careful. But luckily in a test you're not communicating there, that couldn't break down, it's just you in your head. So if you go slowly enough, it'll be fine. There's one more. Whew. There's time for one more? I hope so, yeah. Easy to make a little mistake, mainly because we're talking back and forth and apparently my hearing is terrible. That makes it seem a little worse perhaps. Now base 7, bigger base goes faster, so that's good. So let's just try this table. Maybe some people like the table, not that you have to. So I have 50, 94. What is the highest power of 7 that can go in there? I don't know my powers of 7 that well. 7 to the 4, 4. How many of them can fit in? 2. We're sure about the 2 now? Okay. Take that away and I have left.
292.
Say again.
292.
292. Then 7 cubed. Now I'm not skipping any of them, even if it's a 0. 7 cubed. What's 7 cubed? It's 0? Isn't it like 343 or something?
243.
Oh,
Yeah.
So that's too big, so I still have 292 left. Then 7 squared, which is 49. I can fit some 49s in there. How many?
5?
5 49s can go in, and I have what left?
47?
47. Seems big, but I couldn't fit another one in. Then I can fit in some 7s. 7s in there, 6 of them for 42. So I have 5 left. Let's finish the table. And I guess 1s, 7 to the 0. Let's emphasize it here. 1, 7 to the 0. Which will just be all 5 of them, and I have nothing left, so I'm done. That means that 5094 base 7 is 20565 base 7. The bigger the base, the easier it is in terms of length, so that's kind of nice. If you see a base 3 number, you know it's going to be longer. That wasn't so bad, yeah. The 7 helped, went faster. Any questions about that? Different, maybe slightly different methods, I suppose, for the two conversion directions. Now it gets a little easier, because for the arithmetic we do not convert. We stay in that base value system. Meaning that in the first example, if I'm working base 9, I'm only allowed to write the digits 0 to 8. Not converting it and then converting back. So 7.8 A 6 8, make it a little bigger here, 6 8 2 6 base 9 plus 5 1 7, sorry, line them up, 3 base 9. You stay in that number system. So I'm counting in 9s. 6 plus 3? But there's no 9 here. There is no word, there's no digit, there's no symbol for that quantity. 6 plus 3 is one group of 9 and nothing left over. Just like it was before for the 5s, but now 9s. So the 0 stays, and the 1 goes over. 1 plus 2 plus 7, in my language, is 10. There is no 10 here. 1 plus 2 plus 7 is what base 9? It's one group of 9 and 1 left over. That's the representation for what we call 10. And then I have 1 plus 8 plus 1 is another 10. 1 plus 6 plus 5. I have a word for that. But here, we don't. What is that base 9? There's no 12 here.
1, 3.
1, 3. One group of 9, 3 left over. I find these much easier. The conversion that's annoying sometimes. If I'm staying in the base, I just have to remember my base value and what I'm counting, and then stay within that. There's no real difference.
I have a question.
Yes.
Are you ever going to give us like base 6 plus base 9 or something?
No, because then I do have to convert.
Yeah,
Yeah.
okay, good. So
Apples
none
and
of that.
oranges. It has to be the same throughout. Otherwise, I'm forced to convert, which is what I'm trying to avoid.
Okay.
So that's not going to happen. You get some interesting comparison questions in the additional exercises, and then you have to, either they're really simple or you have to do some conversion so that they can match. Yeah. B. 4, 1, 2 base 6 plus 3, 3, 4, 4 base 6. What's that? Not that much. Okay, right to left. Method is always the same. It's just 6's now that I have to keep in mind. 2 plus 4? We call that 6, but in this case, it's 0 ones and a group of 6 carried over. Then again, 1 plus 1 plus 4 is what we call 6, which is one group of 6 goes over and I have nothing left. 1 plus 4 is 5, plus another 3 is 8, meaning one group of 6 carries over and 2 are left. And then 1 plus 3 is 4. You just make groups of whatever the base value is. Well, not too bad. We should also talk about the quiz at some point. Let's make sure we finish this first. That's what tomorrow is there for. Next we have C. 1, 2, 2 base 3 plus 1, 2, 2, 0 base 3. So 2 plus 0 is 2. I have a symbol for 2, so that's fine. 2 plus 2 is 4. There's no 4 here. That's one group of 3 and 1 left over. 1 plus 1 plus 2 is another 4. That's one group of 3, 1 left over. And 1 plus 1 is a 2. That was a little easier. Questions about addition. If you've done your review with base 5, this should not be any problem. I just have to remind myself of the new group size. Now, subtraction time, which we saw last time, could be more fun. All right, A. Remember, I don't want to be high when I subtract, because I need maybe some room to write down. That may or may not be necessary for you, depends on how you do the borrowing. A is, I don't want to start with A. Let's start with B. I do not have these in order of difficulty. I'm going to do B first. 1, 2, 3, 3, base 4, minus 3, 0, 1, base 4. That 4 is a little big, but I did notice that. They're not necessarily more and more difficult as the question goes. So, 3 minus 1, 2. 3 minus 0, 3. 2 minus 3, no, I need to borrow this one, which then becomes 4 individually. Or you can write 1, 0, but let's not. Let's try the rocks. So then 4 and 2 is 6 that I have. Take away 3 from, which is 3. You can do whatever you want to indicate the borrowing, or really just to keep track of the borrowing. I'm only interested really in 2 things, which is the answer and that you didn't convert out of that base value system. How you represent these, as long as you don't have weird symbols or digits that aren't allowed, really doesn't matter to me. It's just there to keep track of, so you don't have to do it in your head. Now let's do A, which I think is a little more difficult in the borrowing aspect. 6004 base 7 minus 2204. All right. Okay. 4 minus 4 is 0. 0 minus 0 is 0. Man, this is becoming easy. 0 minus 2, oh, nope. Borrow 1. So now this is a 5. Borrowed over, so I really have 7 that it splits into. However you want to write that. Drawings are fine. So 7 minus 2 is 5. 5 minus 2 is 3. Does that make sense? Perhaps we're doing too many examples, but I don't think so. If it becomes really easy because of the number of examples, that's a good thing. It's a good thing. It means you have to do less on your own. Alrighty. Last one for subtraction. C 3000 base 9 minus 2333 base 9. Oh, that's not going to go well. So, 0 minus 3, nope. I want to borrow, but there's nothing to borrow. So I need to borrow from here. There's nothing to borrow. So I need to borrow from this. Finally, something to borrow, leaving me 2. Now, I'm going to draw them, because I think in general it's less confusing. I do have 9 for that column now, but I need to borrow one of these guys, and that splits into 9. Not 9. 8, sorry. No, 9, yes, I was right. For a second I thought, I can't have 9. Yes, when I borrow it, that one thing is a group of 9 individual little rocks. Now I have to borrow another here, which then splits into 9 little rocks that I can now take 3 from and be left with 6. Now I have 8 rocks here, take away 3 is 5, 8 rocks there, take away 3 is 5, 2 and 2, nothing. We are so close to being halfway through the course. Isn't that scary? It happened so fast. Don't worry, the best half is still to come. Any questions on subtraction? Multiplication. And again, we're leaving that second number that I multiply by simple, small, so we can do the multiplication in our head. Exercise 710. First one is 556 base 7 times by 2. So easy. Who can't multiply by 2? 2 times 6? 12. But I'm counting in sevens, so that's one group of 7 and 5 left over. That's not a 15. That is 1, 5. One group of 7 and 5. 2 times 5 is 10. That's one group of 7 and 3 added with a 0. Or not, doesn't matter to me. As long as you line it up. The 0 helps me to keep everything nice. Actually, we should have the 0 there. Because 2 times 50 is 130. And that's what we're really doing. 2 times 5 again, 1300. Oops. Now I add them up, there shouldn't be much carrying over, if any. So easy. So, while I'm erasing, let's talk about the quiz. 5 pages. First page, Roman conversion. See if it's valid. If it's valid, convert whichever direction the question asks. Now we're doing B. 8861 base 9 times a 3. See, these small numbers make it so easy. 3 times 1, 3. I don't have to write a subscript if it's a single digit. 3 times 6 is, I don't mean to insult. 18, but I have to group it by 9s. So that will be 2 groups of 9, no 1s, and I've padded it with a 0. So now I'm doing 3 times 8, so I'll pad it with these 2 zeros. 3 times 8 is 24, but broken up with 9s will be 2 groups of 9, and how much is left over? 6. Then I'm going to do the same thing, but pad it with zeros first. 3 times 8, 24 again, so it'll be 2 groups of 9 and 6 left over. Add them all up. 3, 0, backwards. 8, 8's okay, base 9. 8 again, and 2. Second page of the quiz. Babylonian convert back and forth. If it's valid, of course. Babylonian back and forth. Yes.
On the quiz, for something like multiplication like this, would we lose marks if we didn't write the 9
Yes.
subscript on all the letters?
Unless it's a single digit number. Yeah. But only 1 mark. If you miss all the 9s, I'll still subtract only 1. C, oops, camera. C, 1401 base 8 times a 4. Four times 1, 4 times 0. I can write 8 there, it's a little bit irrelevant because it's 0. 4 times 4 will be over here, so I'm padding that with zeros. 4 times 4 is 16 in groups of 8. That's 2 groups of 8 and nothing left over. Now 4 times 1 will be over here, so pad it with some zeros because I'm really working in this place. 4 times 1 is just 4. Add all of them up. There's no carrying over. I'll just write down here at the bottom. There's very rarely carryover in the addition step of the multiplication.
Please remember to click the like button if you enjoyed the video and to subscribe if you want to be notified of more videos. Thank you.